Hello, welcome to today's video on inverse matrices, where we're just providing a few extra details about them, things to do with their link to transformations, and also some more matrix algebra involving them. So to kick things off, the link between inverse matrices and transformations is that if you want to undo the effects of a particular matrix transformation, all you have to do is apply the transformation represented by the inverse matrix of the original transformation. And so a quick example of that is we've got this matrix transformation represented by the matrix 4, 3, 1, 2. It's applied to a point A, and then it results in the new coordinates 39, 16, and we want to work backwards to find the original coordinates of A. So all you've got to do is realize that what we're saying is that the matrix 4, 3, 1, 2 was applied to this mystery point A. Let's say it has the coordinates x, y for the moment, and we therefore need to find the coordinates x, y. That resulted in the coordinates 39, 16 after that transformation. So all we have to do if we want to find that original point is we have just got to apply the inverse matrix transformation of 4, 3, 1, 2. So 4, 3, 1, 2 inverse. And so therefore now we've just got to go ahead and find that. So of course you will remember the fact that finding the inverse of a 2 by 2 involves swapping around the things in the leading diagonal and multiplying the other diagonal elements by -1. And then also dividing by the determinant. So, or in other words, 1 divided by the determinant. So therefore that would be 8 take away 3, which is 5. And then we're multiplying that by 39, 16. So therefore, if we work that out, that means we are going to get 1/5 lots of 2 times by 39, which is 78, take away 3 times by 16, which is 48, and then we've got -39 plus 64. And that means x, y will equal 1/5, 30, and 25, which is of course just 6, 5. So therefore, the point A has coordinates 6, 5, making sure we're writing them actually as coordinates to the end, as that's specifically what the question asked for. Nice. But here's the thing, you don't actually always have to manually find a matrix inverse yourself if you're trying to undo a transformation. Sometimes you can just use your knowledge of what a transformation does in order to help you know what you need to do to undo the effects of that transformation. So for instance, in this example, we've got the transformation A representing an anti-clockwise rotation of 30 degrees. And so if you want to undo this effect, you could find the matrix representing an anti-clockwise rotation of 30 degrees and find the inverse of it. But alternatively, you could realize that if you just want to undo that, of course, it's just going to be equivalent to doing a rotation clockwise 30 degrees. So therefore, that's really useful because it means we know that A, the matrix transformation we originally started with, is being applied to the point x1 to get the point x2, which was 7 minus 2. So therefore, if we want to find what x1 is, it's just going to be A inverse of 7 minus 2. But as we just pointed out, we can then just use our knowledge of what a rotation clockwise 30 degrees is. So using the general structure of a rotation matrix, which is given by doing a minus angle if you want to do a clockwise rotation. So we got to do cos minus 30 minus sine of minus 30 and sine of minus 30 and cos of minus 30. And we're going to apply that to the point 7 minus 2. So therefore, carrying that out, cos of minus 30 conveniently is root 3 over 2. Sine of minus 30 times by minus 1 is positive a half. We got a minus a half, root 3 over 2 again. And you've just got to work that stuff out. So putting that into practice, that means we are going to get 7 root 3 over 2 minus 1, and then we're also going to get minus 7 over 2 minus root 3. And so again, that means we've got to finish off the question by writing that as coordinates. So therefore, randomly writing it in the bottom left-hand corner for no reason. A has coordinates of, in exact form, 7 root 3 over 2 minus 1, comma, minus 7 over 2 minus root 3. There you go. Another question done. So that is the link between matrices and inverses and transformations. But there's something else I want to talk to you about, which is what happens if you're trying to undo multiple transformations. Let's say, for instance, we're trying to apply the transformation given by the matrix product AB to the point X. And let's say if we apply that matrix transformation, we get the point P. There's two different ways you have of being able to undo that process. One of them is to treat the matrix product AB as a single calculation you could work out first, and then once you work that out, you could then work out its inverse in order to be able to undo it. Therefore meaning that the point X would be given by AB inverse times by the point P. But there is a different way we could go about it. Alternatively, we could keep it as the two separate matrices A and B, and therefore we could try to undo them one at a time. The first one we'd have to undo is by multiplying the front of both sides by A inverse, because an inverse matrix is only going to cancel out its corresponding matrix if it's right next to it. And if we multiply the left-hand side at the front by A inverse, we have to multiply the right-hand side by the front by A inverse as well. That will result in Bx equaling A inverse P. But then if we also want to undo the matrix B, we have to multiply the front of both sides by B inverse, again so that B inverse and B are next to each other in order to allow them to cancel each other out. That will mean that X ends up being equal to B inverse A inverse lots of P. But wait a minute, we did this two different ways and we got two different answers. In one of the ways we got AB all inversed, and in the other way we got B inverse times by A inverse. What does that mean? Well, it means these two different looking expressions must be the same as each other. So therefore a little result to be aware of is that if you're doing the inverse of a product of matrices, then therefore as part of doing that, you reverse the order. So AB all inverse is B inverse times by A inverse. Remember, order of matrix multiplication does matter, so therefore this change in order does have an effect. Cool, so that's a little fact to remember. Only rarely comes up, but when it does, it catches so many students out because they forget it. But there you go, that is all I wanted to cover in today's video. I hope you found it useful, and I'll see you in a future video, possibly one on matrices, because we've got loads on this channel. Check them out. Goodbye.